and welcome to Assembly Audible. I'm your host, Jennifer Pierce, multimedia editor with Assembly Magazine. And today we're broadcasting from the 11th Annual Assembly Show in Rosemont, Illinois. Joining me from the Community Hub on the show floor is David Cash, Technical Application Specialist with Mountz. David, welcome to Assembly Audible.
Oh, thank you very much. This is pretty exciting.
Yeah, absolutely. So Cash has been in the torque control industry for nearly 25 years. It's a long time. He focuses his efforts on solving challenges that customers sometimes don't even know they have related to productivity, quality, and safety improvements. Cash has seen many unique and challenging torque application challenges in dozens of industries and thousands of customers. He provides training to internal reps and to customers one-on-one or with groups, and is a known presenter at industry events. Okay, so now we know a little bit more about your background. So let's dive straight in. So tell me, from your perspective, what are you seeing out there in terms of industry trends in the manufacturing process?
Well, right now, currently, it's a progression of the Industry 4.0 type of standard where data is really driving a lot of what's happening during the assembly process. With the advent of a lot of different companies that are utilizing MES systems to either provide work instructions for their operators, they want to be able to capture the torque data that happens during those assemblies to keep within their records, to make sure that everything was done correctly. If there's any liability issues from their point of view, if they're a subcontractor for another company, that they have that backup information regarding what was torqued, when it was done, who the operator was. All of that information is what's driving today, being able to capture that and input it into different types of MES systems. So.
Okay, very interesting. So I understand that Mountz, the cordless screwdriver, is nominated for New Product of the Year at the show this year. And you, upon request, thank you so much, brought the tool to show it to me and all of our listeners and audience about it. So tell us about the screwdriver.
So this is basically a smart screwdriver, or in this case, a wrench. It does have wireless capabilities, so you can connect this tool to a controller. It can then capture that data from the tool in real time. Again, being able to put that information in some other repository that you might want. It does have a transducer built into it, so it's not only providing the torque output, but it's also measuring what that torque output is in real time. It has the capability to have 15 different preset values. So in an application where you may have different torque values for different fasteners, you can accomplish that all within one type of tool. The battery portion of it makes it very easy to move around in certain assemblies where a corded type version tool may be a little bit of a hindrance. And there's some other unique features that we can talk about too. So.
Okay, awesome. So, I want to retrace the steps just a little bit. So when you call something a smart tool, what are the elements what does it have to include to be considered a smart tool?
So in this case, it can either collect or transfer data that it's capturing. It gives you the ability to program a certain preset to respond a certain way to an application. So for example, if you had a scenario where you had a really long fastener, right? And you need to torque it to a certain tightness, but the RPM that you're using is kind of slow. We can tell the system, well, run it at its max RPM for most of the fastener, and then slow down right before it begins to torque so it does it accurately. So there's those types of things that allow you to control what happens during the actual rundown. That makes it a smart type of system.
I see. So when you're collecting the data, you want to analyze that information to make sure that the connection the torque, as you so kindly explained to me before we started recording, is essentially perfect? Or is there perfection in your world? I don't know. Does that exist?
There is usually a tolerance
Okay.
that you have
Okay.
for different levels of styles of tool. So you could have a pneumatic style of tool or an air tool that has a certain percentage range. You can have an electric clutch tool, which is basically just is run by a spring clutch, so it has one torque output setting. And then you have scenarios where you're using a smart tool that does give you the ability to program it to different scenarios within the different presets in the tool.
Okay, so would you mind to show me and our audience some of the features of the screwdriver?
Ure. So on the display itself here, it gives us the ability to control which preset you'd like to use by
Can I pick
using
it up?
the
Is that
soft
okay?
keys. Yeah.
Yeah. Okay. This is my moment.
That's right.
Okay, I'm sorry. This is your moment.
Excellent, no problem. So so we have these soft keys that are oriented to the menu system there. So if we want to change a preset, we can move these up, and it's going to change it to preset 2, preset 3, preset 4, and so on. You can also see exactly what the target torque is that you're going to be running to. You can also see how much time it took in milliseconds to run that fastener down after you've been completed. It'll also tell you how much turn has taken place for that particular application as well.
Okay, so this is cool. I love this. I need one of these. I'm not sure what I would do with it because probably, as you can tell by the way I'm holding this, I don't really use tools like this very often.
Right.
So I understand you have it set now to preset 1, right? Yep. And it's in operation mode.
Yeah, in the operation mode. So if you just pull the trigger, the way that we have this set up here is...
I will not be pulling the trigger.
You can.
Where?
Right here, right there.
What's
So
going to happen?
this will spin the drive, and then it will stop.
Oh my God. Okay.
So we have it set to basically what is called an angle tightening, which means it will rotate a certain number of degrees of rotation and then stop.
Okay. So what does the 22 here in the upper right mean?
So that is the maximum torque that it will allow during this operation. So if you go outside of that range during this turning assembly, it will then provide you with an error and say you need to reattempt this
That's
fastener.
cool. So, and not to sound silly, but if you were to be using this on an assembly line,
Yep.
would you be like holding it down like this or like up, or how do you hold it?
Yeah, typically you're going to be using it if you're in a situation this way, you're coming down on a part and you'd be doing your tightening. You could also do it horizontally this way as well. So that would give you primarily how you would be using the tool that way.
Okay.
The other nice feature is we have a built-in barcode scanner. So if you want to change the preset automatically by a barcode scan, all you have to do is double tap the trigger,
cool.
and it will then take you, and you can scan a barcode from that. So
That
it will
is
automatically
wild.
change the preset that you're working with.
That's
So,
really neat.
Yeah.
I love that. So the last question about this. So, okay, I'm really interested in data analytics. So, like, what happens to the data after you collect it? And I mean, like, do you get, for example, does it send information like, oh, something's not right, or it's not, something's not doing something right? I don't know what I'm trying to ask here, but
Yes.
do you know what I mean?
Yeah,
Like,
there is different layers of error proofing that are built into the certain presets that you might be using. So, for example, a common tightening error that happens would be a cross-thread type of issue. So that is basically where the threads don't meet correctly, and the nut will bind up right at the very beginning of the operation.
Okay.
And in this case, because we're looking for a certain level of torque, that torque would happen because of the binding, right? So we can tell the system that it must meet a minimum amount of turn and meet the torque value. If it doesn't, then generate an error. So we would get a minimum angle error that would be displayed for the operator. They could then go ahead and reattempt the fastening. So,
And that's probably just one example of how the data can be utilized, right?
Yeah, for the error-proofing functionality, that way would definitely be it. For the data collection, it is really dependent on the company and how they want to use the data that they get.
Okay.
So we can provide them with the data,
right,
and then they can parse it however they want.
Awesome. Oh my gosh. Well, thank you so much for showing me the screwdriver, and best of luck
All right.
in the product of the year competition. I have one more question, and that is, I understand that you are hosting a learning theater presentation today at the Assembly Show. Can you tell us a little bit about that?
So we're going to be talking about friction and how that can play a part in a threaded fastener assembly. Because keeping things consistent is really, really important when you're doing tightening, especially on very critical type of applications. And any introduction to different types of inputs that may change that can really change the overall joint assembly. So that's what we're talking about.
Okay, awesome. So if our listeners want to get in touch with you or learn more about Mountz, where should they go?
They can go to our website at mountztorque.com. There's a special link on there, so if you need any applications questions, you can hit the applications team. We've got several different engineers within our group, and they can get the answers that they might need.
Well, thank you so much for your time today, David, and enjoy the Assembly Show.
All right, thanks.
Thank you for tuning into this episode of Assembly Audible. For more insights on assembling discrete parts into finished products and the people behind it all, visit our website, assemblymag.com. I'm Jennifer Pierce, signing off from the Assembly Show. We'll see you next time. Thanks for listening.